side, we introduce a new interface, which is F1C complement, and the signaling is actually now going as a data through the 5G network. So this one is an important concept, and it leads, in our view, to a more generic architecture. This is what was proposed in the ITU contributions, that we have the user plane functions and we have the mobility orchestrator. So service functions, are there, and we can see that now, as a result of this, since the signaling is exchanged with the UE through the data plane, all services can be treated uniformly, and of course, the service orchestrator can collect the requirements from the UE via various service functions. So more in the existing 5G core, what we are proposing is the RAN and core in terms of the control plane. They are reorganized into 3 different types of functions, and which is what is sort of shown here. And the data path now carries both the usual application data and also the signaling messages. So this way, we believe that we can address the problem of the signaling overheads, because now it is flowing through the data plane. So our proposal's basic highlights were that we have disaggregated the control plane, and therefore it becomes more modular. Because now the UE signaling is being treated as a data, there is a possibility of use case specific variants of the UE signaling protocols, and the impact on the UE signaling messages is therefore not necessary. We can also actually, more importantly, have a very flexible signaling function placement and chaining, and essentially we achieve the decoupling. In terms of the control plane now, it primarily controls now the user plane. It doesn't exchange now the signaling messages with the UE, and therefore there are simpler message flow and protocols. So as a result, we achieve that kind of a simplicity. It also reduces the load on the control plane, because now the signaling is being a part of the data plane. So basically, we are proposing essentially somewhat a change in the paradigm, that we achieve the disaggregation at the RAN level, more disaggregation at the control plane level as well, and also treat the signaling as the part of the data plane or a payload. And as a result, we believe that there will be a less load on the control plane. All services can be treated uniformly. And of course, if you do further division at the protocol stack, which I pointed out by introducing the open flow types of switches, then we can even achieve a uniform interworking. And of course, this will also lead to the core networks having the knowledge of the radio access networks in a better way, because the radio access technologies information is now available at the core. And plus, it also helps in the dual connectivity of the UE, because you don't have to maintain the state for each radio access at the core. So I think in conclusion, we are looking for, now we're going from 5G or beyond 5G, we are looking for a very massive and heterogeneous architecture providing ubiquitous connectivity with very high speed data rate, and combination of sensing and intelligence to be there, and also of course the sustainability. There are of course various spectrum options. There are more options in the low end mid bands, and we believe that in order to have a scalable and flexible architecture, of course, I gave some proposal, but there can be other variants or other proposal as well. But essential principle is that we want a service-driven core which can integrate multiple radio access technology in a flexible and seamless fashion with not much complexity increase in the control plane and not much load on the control plane with the increase in the data volumes. One more thing that I have not talked about is that we would like some of these functions to be energy aware. Again, I did not get into the details of how some of these disaggregations can be virtualized and how the network slicing can be introduced, and each network slices can be configured for different use cases and for different applications. And of course, the architecture needs to be intelligent, AI and ML driven design. And hopefully, I think in some cases, either for the private networks or for some other use cases, because our work group has also worked on the frugal 5G case. There, we may not need the core networks if all the use cases are fixed or stationaries. So a core-free services should also be possible. Of course, we need the billing and authentication, but that can be done without core also. That can be embedded in a controller. So that's what, this is based on several of our contributions that we have done to the standards, both in IEEE 1930 and ITU Y.2325, which I mentioned. There are a couple of journal and conference papers, and we have a US patent granted on this uniform control of multi-radio access technology networks, which some of the ideas I presented here. So thank you very much. I think, thanks a lot.